Okay, so I'm going to look at modeling. So what are the components that we're going to have, right? So we just quickly sketch out this idea of the root. Ooh, this is a really light pencil. I left my sketchbook at home. That is way too light. There we go. Aha. All right, so we have this roof system. I want to create the I-beams that we're going to lock into place. So that's one component is the I-beam. And then we have the columns. And we're going to make these a different way. And there's also going to make, let's say, the pin connection at the top. So those are three things. So we're going to actually make one of these as a 2-point adaptive. Because although this is simple and flat here, we might want to play with it more later. The columns, we're going to make generic models, just straight generic models, but we're going to give it some parameters the same way with this thing. So we're going to make one adaptive component and then two generic models as a way of putting this together, but also letting us kind of mess with some stuff later. Let's see. So when I first do this, I want to draw again. I kind of sketch stuff out before I've done this. So with the beam, we've done a box beam in the past where we had two adaptive points. We would make a line between it. Remember, we nested points on that line and we set a value for its offset, right? We then hosted a point on top of that at a height and a point on top of that at a height, right? That let us make a reference line around. And when we made object, we went equal to both sides, right? That's how we did that one. Now, what we're going to do is take that same idea, but we're going to actually create an I-beam. And so what's interesting is if you think about it, if we just look in section, if we think about it, what we did before was just make this, right? Center line, we extruded out this way and that way. That's kind of what we did. We just made a simple box, which could have been nothing more than that. So what I'm going to do is I'm going to use the exact same logic, but we need, instead of just doing this the whole way, we actually need one surface, two surface, three surface. That makes sense? Where before we were just doing a beam with one surface, right? Well, that was extending out each way. So, but here we need 1, 2, and 3. So what we need is, there's the baseline point at the bottom, which is that one there. We need another point here, another point here, and then the original point at the top for the depth. Okay, so we just need actually 2 additional points here. Okay. Now we're also going to be able to offset the width for the thickness in the center, but we're also going to want a second width for the overall. So we're going to need a couple more parameters, but we're going to use the same logic to do this. So this is just a nice way of kind of walking through and creating a thing where we can actually then change this quite a bit. Okay, we are going to do the offset same way again. I'm going to start it from the beginning again. If I was doing this just on my own, I would probably grab this original box beam and just make a version of it. So save it as something else and then give it some other parameters. But I'm going to start from the beginning as if I hadn't made this other one. Okay, we're doing it. So that's the first thing we're going to do. Let's do this generic model. Switch to share screen. All right, so we're going new family, hit G, generic model adaptive, that's it. Oh, what's going on? Okay, point, boom, boom, sweep, grab both, make them adaptive, zoom in, reference line, make sure 3D snap is hit. I just turned on Revit, so that button hadn't been done. I snap once, make sure it's working. Serial around, hit again, zooming in again, point, boom, boom. Grab the second one, tell it to look the other way. Sweep and grab both. Sweep and grab both. Segment length, and I'm going to make this parameter. And let's call this end point offset. Just be really clear. We're going to make super long names. You don't need to make super long names. I'm going to make them for clarity. Okay, but you could just have gibberish if you remember which gibberish is which. Okay, so I'm just letting them be there. We're gonna play with those later, right? Now, just like last time, I'm gonna grab another point, SW, tab till it's the flat one. Tab, there we go. Click and then drop. Okay, SW, tab, click and drop. Now I know when I select, if I just touch on it, I grab that first dot loop on top. I'm gonna grab this, make a parameter and say, we're gonna go overall depth. Okay. Now, that one's set. Let's just, okay, yeah, let's do this right here. So now overall depth, but they're sitting right there because that was set to 0. So remember, we can go up here and we can get into our parameters box and I can say overall depth. Let's go the full 6 feet, like it's gonna be, right? These big old beams. So they jumped up 6 feet because they knew where to go, right? Every way that I've been doing the tutorial so far, we've been making the object and then making the parameter based on it. We can actually just make a whole bunch of parameters first because I know I'm going to have different things, right? Makes sense? So I'm going to just right now say, hey, I want a new parameter that's going to be, let's just say, we're going to keep it simple. Just say metal thickness. Okay. We're also going to make another one that says overall width. And let's just set some parameters here so that way when we assign something, we know it moves. Let's say overall width, let's say 2 feet. Metal thickness, let's just say 2 inches. Okay, so we can, if you know you have a lot of stuff, if you thought through it, you could just do them all at once and then it's there. Why? Now, I've kind of done this different ways. Kind of depends on how you want to do it. We could go and set another point on this and lift it up a ways, another point on this and lift it up a ways. We could also just make a reference line, grab it from there to there, and then set points on this. So now those are set based on the distance of what's happening. Or I could go point SW in the same way we did before, set a point here and tell it to raise up a distance, let's say metal thickness. So that went up metal thickness. Or I could grab this one and it's going this distance, it's looking down that way. I can say, hey, look, segment length, metal thickness. 2 different ways to think about it. Sometimes it's nice to just think about the idea that you're making, a reference line and where you're placing it. Both of them do the exact same thing. Okay, this is what's interesting. I normally, actually, I'm going to be really weird and do one way and one the other way and see if that screws up. And it's a bad thing to do. That's a bad idea. I am not going to do this way, even though I like this way. I'm actually not going to do that. I'm going to delete this. I want to take this. And if you delete it, the spot will go away. I'm going to dissolve it so the point's still there. I want to make sure that this stuff just really quick is still. I move it around every once in a while just to make sure everything's working the way it's supposed to. Just a smart thing to do, right? So just as I put that point there, I'm going to W that on there. Okay. I didn't know I would have done this at the same time. You notice I have to do them this. Okay. Okay. Now, this one, I want the metal thickness, but I need it to go down. So I actually need a negative number here. So do that really quick and say, hey, I needed another parameter and say, make a new one and say, I'm doing this the wrong way, just so you can see it. I'm going to say it's the metal thickness negative.
It's smarter. Fine. We're gonna do it with the line because the line's smarter. Reference line. It is just smarter because you don't have to make that a parameter. So I can do it one line from here to here. Because we could just have it look from one end and then look. Why is it? It's fine. Be off axis. All right with me. It's fine. Okay. Let's just make sure that moves accordingly. Okay. Now, this is what's nice. We can just put 4 points on here. 1, 2, 3, and 4. We want to make sure these ones are looking up. These ones are looking up. Does this make sense? Now all of a sudden I'm going to grab all of these at the same time and say, I want all of these distances to be metal thickness. Segment length. Metal thickness. Okay. Then I'll go to their ends. Does that make sense? Now, for this really quickly, I'm going to jump into metal thickness and make it like a foot. We'll change it later. But in essence, I want to make it easier to grab and do stuff, which is hard. Let it be about you. Okay. So now we're going to make some objects. And we're going to have to add some stuff to it. So reference line, 3 steps on. I'm just going to make each one of these. Come on. No. Now you can, I have got it to work where I don't put the line back over that segment. Like I can grab that one. Sometimes I just chain all 3 of them. It's just, you notice it keeps complaining that it's slightly off axis. It's better if it's like farther off axis because then it knows it's just off. Stops complaining. So I still need the line there, and I still need the line there because, and I still need the line from here to here. That line doesn't exist individually; it's the whole thing. I got that. I got that. You grab them individually. So let's start with the sand because it's the smallest one. I'm grabbing these 3, creating form. I want an object. I want to tell it. I want this to be metal thickness, and I want this to be metal thickness. And it's going equal both directions. Right, so center line on there. It's nice and simple. Now we don't have a parameter for this other thing. If I want to make it like easy, getting in the habit of just hiding stuff so you can select stuff easy is a good habit when you're working. Object again. I'm going to set this. We don't have a parameter. Oh, we have overall. We're going to put this overall width. And this will be incorrect. So we're doubling the width, right? So we'll come back. Do the same thing down here. Form. Again, set it to those parameters. And say, okay, I want to make this a little smarter. Again, reset. Okay, so we have this thing. We can make sure it flex. Let's change the offsets a second to say like 1 foot here. Okay, so that worked. And I kind of, before I spend too much time, I'll grab it, make sure it all moves. Okay, that's all good. But it's not what there's actually some of the parameters you can work the way I want. Like I want some easy stuff later, like overall depth and overall thickness should be correct. Overall depth is correct, the 6 feet, 6 feet. My overall width isn't, right? That parameter. So I'm actually going to come back in. I'm going to rename this one and say it's actually half width. Right, because that's what it's controlling is half the width, right? I'm going to make a new one, say over, Jesus. And now I'm going to take that overall width, copy, put it in half width, divide that into overall width, 3 feet, should make 1 foot 6. Apply, okay. Now it doesn't look right because that metal thickness is ridiculous. So let's say 2 inches. Now, right now, I went simple, but I'm making the webbing twice metal thickness in this. We should do the same thing. is right now, the webbing would never be thicker. Remember, because why would the top chord, bottom chord be thicker? Why would we want the top chord, bottom chord thicker than the webbing? So these are bending, right? So why would we want the top and bottom thicker than the intermediate member between? So this in bend, when anything's in bending, remember, what are the, let's say there's a neutral axis and then there's the blank and blank at the top and bottom. What are those things at the blank and blank? They're compression and tension, and they're on the extreme fibers, the extreme things. So you want to put as much, the whole point of the I-beam is to push material as far away from the neutral axis, right? And so that middle webbing is just strong enough to get the two chunks away. So in theory, this isn't really logical right now. So let's go and correct that a little bit. So right now, let's make it to where the metal thickness is actually the same everywhere. So I'm going to do the same logic I did with the widths and say, you know what, I'm going to go in, I'm going to say overall, I'm going to say metal thickness is going to stay metal thickness, but I'm going to make a new one and say half metal. Okay, and I'm going to take metal thickness, copy, half metal, V divided by 2. Okay. Now I'm going to just grab this object right here, tab in to where you get the whole thing. And now look, I can just go back in and say, I want you to be half metal and you to be half metal. Makes sense? Now, whatever I change the metal thickness to changes one for one, and the other one split half, and it still makes it the same, right? So now we got this great little I-beam. I'll find a Danny, can go everywhere we want. Now, I like to do some stuff with the ends. And let me stop sharing really quick. So what happens in an I-beam a lot of the time is that, say in Axon, we have this happening right now. When we're making connections, there's a lot of times we do something like cut some of the end so that they can connect together. Like if I want to connect an I-beam into this I-beam, I might have another I-beam come over. Dash, 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 dash. This will make sense in a second. So I'm having an I-beam come in and connect to this, right? So I want you to think is, let's see, over, down. Okay, but so this one's coming into it, but what we've done is we've cut away the cord here, and we've cut away the cord here. And does that make sense? So we cut it down to where in essence it's we let this webbing extend out. But what we've done is we've just cut away. Yeah, that makes sense. So we've done. Okay. So that can then be like we might have we might use a little bracket. And both there and both there, right? And that's how we might test. So the idea that we create a tongue by putting that forward that we can then put something to, right? I am recording the video, see. So that's what I want to make this happen. But what's nice is we've actually already created these three things as different objects. So this is really nice. All we're doing is controlling these by telling them how far we want them to go. Because I'm gonna keep it one way, really simple. Sharing again. There are different ways this might happen. I'm gonna do it by saying, well, we already got the offset, right? Controlling a bit of stuff, which is nice. It's great. You know what's kind of interesting is that you can align the points to things that if you just want to kind of get it to look right again. I want to take this center and just like we did on the other beam, make an offset it. So I'm just going to go in, kind of here, tab, that one. Create extrusion. I'm going to change this to new web. Geez, I'm just all over the place today. It's hard. My head's one way. I can't get away. So I'm just going to leave that so we can change that. So in essence, we can pull the top back by just our normal point offset, and I can extend the webbing further if needed. It's going to come in handy with this project.
It's in that. It keeps the same electric painted, it keeps the same properties. Where they extended from, because like you just remade it, so that it keeps the same thickness of the web without.
Right, because it's just that surface. It's just, so when I change, when I change the thickness, that. There we go. It's saying that surface. So yeah, you watch what happens. I'll change the middle thickness, and because it's all about like parent, like what isn't grandparent, parent, child, and all of it's lineage, right? And so when I say extrude this out, and I say the extension, okay, we come back in and say change metal to 4 inches. That changed the base, which changed that surface, which changed what was extruded. It also it changed because that point changed. That meant, you know, like all of those things. So, that is the base logic. Okay. Is that what you meant? Like the width of that stays the width, whatever. Yeah, because it's just not. This thing doesn't even know that parameter exists. It just knows the snap face to extrude out. So you got to feel like it's only looking at the thing above it. You tell me what to do. You tell me what to do. Okay. I'm going to now file save this. Well, we could change it. That's the whole thing. So these are all parameters that even when I bring it in, I can make different types. And that's what we're going to be important. Like with the other one is getting used to just renaming it and not just using it dry. Because when you use it as it is, and then you bring several things together, you've got the same thing with different variables named the same. So this. Yeah, we get in a bad habit of not naming. I do it too, because I have the time I'm leaving it project, you know, element 6 or whatever. All right, so where have I put my stuff? I put it all in here, and I got a link, and then I got my basic components, and then I'm going to pretty much name it. I think I have a W in here that's terrible, and I'm going to just rename it over this W flange. Just kill that one. That's fine. So I named it adaptive. Our 2-point, so I know it's a 2-point adaptive W flange. Okay. And it's going to go, do you want to do this? And I was like, yeah. And it's like, ah. All right. So we got that. Now let's play around with that a little bit. So let's go and make sure it works the way we want. File, new potential mass. Ask that. So why would you ask it if there's no real option? Understand? So as a testing ground, I like making sure stuff works by doing this. So I write 2 flat lines. I'm just going to grab this one, raise it up, grab this one, raise it up. Divide. I can load this in, and we can snap. Okay, so it's laying flat. Remember, this is a question that people are asking. Well, it's not doing what I want to do. But let's start with this and say, okay, arrays, it changes, it moves, it's looking good. Now, let's actually look at what happens when we change this a little bit. So if we go in here and let's just say always vertical, save, load. Okay, so these are always vertical. Now, there are times where you might want it to be perpendicular to the surface. Let's say this one right here is not perpendicular to the surface, it's vertical, right? Makes sense. But sometimes it's like, well, I want it to, if it's a curve, I want it to roll with curve in a way, right? So let's go back in and say, maybe you can just tab in, if you don't have it open, tab in. I'm gonna take that off. These two. And say, let's do instance Z host. Let's see this one. Forget that sometimes it's going to get, you don't really have to say, I'm doing it just to make sure everything since we're recording. So now what's this doing is these are points on a curve. So the instance is the point, and the point is there's an up and down. So that's one effect, and you may want that sometime, you may not. But let's go back in and now say, I'm just going to tab, double click. Now I'm going to grab that one, grab this one, and say global Z post Y. This should be the same as the first one. That's the same as the first one. So that's why somebody was asking. I think the always vertical just pretty much is the global Z there. So I will do. We want. That's fine. Google's instancy is usually what I do. Oh, let's see what this one is. And then next time I'm going to make a surface and lock to the nodes, and those nodes are going to be looking in that direction. Yeah. Okay. And let's do some like math, because that's looking the right way, but not doing what we want. Watch what happens when we delete these. Make a surface. So now that surface is the object. And we're going to grab that and say nodes, we get nodes. Let's see what happens when I do. Just want to see what happens if it grabs these nodes versus those nodes. It's usually surface facing. That seems like it's paying attention to the surface really. Okay, yeah, that's what it is. So for the end nodes, this is why I never like having end nodes, because that end node was actually on the line. And so then it was orienting like that was still along the line. Or so if it's about a surface, I think it was like, what is the node has an orientation, right? Is the node on the line where up is down the line, down the line, you know, or is it on a surface where up is up? So kind of just understanding how you want orientation and how you want this thing to play to it. So let's say it's on the vertical. Let's see what happens when we say always vertical and then put it on there. Does it fight or does it still? Yeah, see the surface still overrides. Global. So if you want it to be perpendicular to the surface, then if you want it to be perpendicular to surface, then using a surface, then it's perpendicular to our. Yeah, so the surface can. Oh no, there it broke away and made vertical. So the global Z will break surface. That's not perpendicular to the surface. Anyways, very little controls. So we have this beam. That was the first thing, but we're just going to be pretty much using it flat. But we got that started. Let's do. We know it just works. We can be fairly correct, and let's say, what is our size? Let's say, actually, I'm not going to do it. I'm just going to do 60. Here while we're doing videos. I'm gonna go reference line. All flat. And we can have it snap to these. Yeah, snap, just make sure it's correct. Snap. I grab to these, I can say. Surface, far right one's always flat, remember? We can grab that surface divide. Let's put these at 6 feet. And 6 feet, so we're getting our grid. And so what's one way we could do this? Well, we can turn on the nodes. So we can snap to them. And I'm gonna do something here. The way that was, remember we were saying the way it was really done is there were really long ones, actual full length ones, and then pieces brought in, right? So I'm gonna grab this one right now. Just snap it and say, look, there's one that's gonna go from here all the way to here, and we'll repeat. And then there's also gonna be little ones crossing the other way, going from here to here that are gonna repeat. Right now, these are the same. Well, I'm using the same one. I didn't change the name, right? But let's just see what happens when I do that. Let's grab that, do that. Okay. So we got this sort of, it's not looking correct, right? Because I actually want different parameters for these ones. The sizes are the same, the whole extension and ending and offset, all of that. So what I want to do here is I'm going to double click on this one and I'm going to say, I'm just going to rename it to begin with and say big steel. And I'm going to do the endpoint offset. I want these to go to the end. So let's just put 0. They're going full way. Metal web extension 0. These are just the big ones. 0 both ways. By okay. Now that actually changed all of them, right? But I'm going to double click on this one again. I say duplicate and say that's blocking. The one's going the other way, right? Now this one, I want that end offset to actually be back. What was our web thickness, which was, or no, our overall width was 3 feet, so 1'6". I'm going to pull it back 1'8" so we see it. So that's pulling it back beyond the flange that is of the one that's coming into. But now I'm going to do the web extension 1'6". Okay. Okay, but nothing changes because nothing's told that yet, right? If I can go in, those are the long ones, those are the short ones, and just say, hey, look, I want you to be the other one. Okay. Now we got the other one in here. Now the edges look bad. It's actually going correct if we're cut through this, like every little guy, the little ones are extending in, right, to that. Like I'm getting that, but this edge doesn't look right. Okay. So what we can do is say, well, yeah, there's always tab, grab that one, grab that one, grab that one. Now I got my big steel. So the idea that like you can do a pattern base and then clean it up after, one thing that I would do kind of funny. So this would be a way that I would kind of be showing what actually happened, and how we want to mess with it or not. So I'm not going to do too much more with this. There's lots of ways to play with it. What's interesting is because I did these on reference lines first, we can actually look what happens when this is a ruled surface and how we could create hyperbolic forms with straight lines, especially with the blocking. How would actually do that, and how each segment would have to change for that, so we could actually start to make different surfaces. So the next thing, the column. So this is a start. We can use that. How we were saying we're going to use a generic model to make the column. Let me go back to drawing really quick before we do it. We're going to make this column. Remember, it's in plan. What did it look like? It would look like two I-beams crossing each other, right? Think about that way. It's an I-beam this way. in essence, I'm getting this way. Right? So, whatever in Revit, if we want to be able to control it later, we need a reference line for each thing. So that what I get in the habit with is, in AutoCAD, they used to be called like a X ref or X lines. But so what I do is start to look, what are the things I want? There's a center line here and a center line here, right? Everything's coming off the center line. Those overall width. There's thickness, thickness, right? Those all have to have thicknesses. There's actually the width, and that's the same. Width, that's the same. There's the width, that's the same dimension. That's the same dimension, right? And then there's width of the steel on the inside. Okay, so there's a whole bunch of those settings. Right on this version, I'm going to do the column straight. It does taper. I'm not going to get into this one because I just want to show how to control these things more than the tapering. Okay, so the first thing I want to do is that. We're going to go into File, New, Family, hit G, bottom. So this isn't a this is what's weird is that you get different commands. It opens up all the windows, reference, front view, WW, get rid of everything except for when you're on stuff. So we're going to go RE and start to just draw this out. Don't sweat it being correct. I'm just sketching out what I want. I'm going to get these first ones done. 1, 2, 3, up, equal. Okay, let's grab this one. We're going to make this base width. Okay, grab this one. What do we want it? Base width. Okay. But that's set up. So now we got approximate size of this and everything's going inside of it. Right? So now I'm going to sketch, I'm going to quickly just rough out all those control lines. Again, I'm going to come back and control them later, right? Right now, I just need them in place. Now, what I realized is how much being able to do that right there is probably from spending years hand drawing and the idea of understanding just like what are the construction, where's the ruler going, what's lining up. So it's just like a way of understanding the drawing. And so that is kind of it's a skill set, but it's also it's like you start to visualize what your goal is, right? What are the elements? What are the controls? Okay, so now we want to control this stuff. I'm going to do some quick little ones that boom, boom, boom. Again, equal. 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 Like that, we need this one. And this one. And sound effects. All right. I want to control this stuff. So we want the width of the overall width of these I-beam flange. So we want that. It's going to be the same thing over here. Grab this one, name it okay. This one, make it be the same width. Okay. So those are there. Let's do because this is a column and they made it. Now we'll do the same logic of like metal thickness and the half metal thickness for the center webbing. It could have been that the center was more solid because this is a column. It's not the same thing. Let's make it easy. Let's do that. Let's just have one metal thickness. I'm going to go in here and say new. And we're not going to deal with the whole hat stuff. We're just going to let the center cross be 2 inches where the other ones are 1 because it's not the same as bending. They might have been different.
Yeah.
So this is, and I think for the next one, it's basically the same thing, but for the. We control.
We could, exactly, you're making, exactly, when we grab something. When we're in another file and I touch something. And you have the ability to make a family parameter there. Or if there's a dimension. And I grab it and I'm hitting that, that's making a family type, create a parameter. If I go into here, I can just make them raw and assign them. So yeah, all those, there's just the idea that you're telling it that I want to control it later.
You said it.
Right. In essence, by naming something, you can control it later. If I don't name it, then it just exists the way it is. Okay, so yeah, the thing is like by naming it, sometimes it's yeah, they like to use a little bit of different terminology, but it's all just, you're making it a parameter that you can change later. So the same way, like I'll grab this one and I say, hey, look, I want it to be the metal thickness. So I can just go metal thickness. Metal thickness. Now this is where we could be fancy and say, oh, that's what we'll do. We will make the same. I'm just going to make the dimension. It's equal. But I'm going to take this from there. I can grab that one and say middle thickness. I have to say the half thing because we have the center line and it's dividing it already. That's this was not control. Just happened to make sure that it's actually controlled. Like that one just happened to be the thickness that one was set at the time. If all the text is getting annoying, if you just change the scale of the drawing that it's ready to print at, because it's gauging it for how you'd be printing it. So you can
Professor, can you show your screen?
Oh no! Oh, you got to yell that shit out earlier, man. I've been clicking for like 20 minutes. Oh man. Okay. That means it's not recorded. You guys, sorry. Share. Okay. Okay. All right. Well, there's a whole lot of work right there. So what was done? A lot of reference lines. A lot of it's. Yep. Okay. I did this in another video too. I did another video too that you can look at. Yeah, man, I'm not redoing it. That's what it is. You guys got to try it. You guys won't pay attention. I'm sorry. If I'm clicking that much and not drawing, I'm in here. And I apologize, but yeah, we're not. So the idea was setting up this to look exactly like the drawing I sketched. Setting parameters the same way we set dimensions and other things. The idea that we were selecting them and then controlling them with parameters the same way we could build them in here. So we're setting up a base width. Let's say that base width is 3 feet. Should change all that flange width, let's say 6 inches. So it's just changing the reference line. There's no actual object there yet. And this is what's interesting. So now once that's there, let's go create. We're just going to do an extrusion. Okay, this is like nothing more than just dumb SketchUp, really. I mean, that's the whole thing with generic model is that it's pretty much actually let's just cancel this really quick. You can see generic model is pretty much basic SketchUp revolved sweep 1 rail and in essence sweep 2 rail with different shapes. So that's how you can kind of reverse engineer most forms through those things when it's an object. They seem dumb and simple, but you can get really complex things if you just understand the shape that you're trying to extrude, right? Cross sections of them. So that's what we're gonna do is we're just gonna do a simple extrusion. We're gonna draw the line and yep.
You make a comment.
Oh, when I make it, when I make it a parameter? Yeah. Well, so it's just the little thing on the side, so it's the create parameter. Yeah, and it's kind of like it's kind of weird, in each of the modeling things that you touch on something, and if there's something available, it pops up right to the side, like. So like, visibility, like we could make this top flange turn visible or not visible by making a parameter on and off. Right, so anything that's got the little button next to it, we can control material. We could have it change its material type based on things, right? So yeah. Okay. So with this, now we'll make the form. I'm just going to say create extrusion. 2, 3. And I'm looking just snap. You can be fancy and I'm actually just trying to, because the grid's already done, just snap everything on the grid. I know what it looks like, so I can. It knows that we want it there. We can go through and lock everything. You could lock everything to each one of these lines, but it knows it. Because it's where I was like, we're drawing it because you see the green arrow snap on the corner, but they have things called weak reference and strong reference. So this is weak reference, but nothing else, like I can pull it off, right? So you don't want that. We want reference under control because we're controlling reference lines. Right? So I just did that around and hit OK and look at DD. We got an object, right? I could grab this. I could push and pull it. We could still push and pull all these things. It just now, as soon as we pull it off that reference line, our parameter won't work. Right. So let's look at something really quick and just test some of these parameters. Let's say metal thickness 1 inch, base width 2 feet, and flange 1 foot. No, let's look at 8 inches. 5. Okay. So we've controlled every part of that. It seems to be flexing well. Okay. Now we can also just touch this element and say, what is the total height and extrusion 24 feet? We would have an object like this. Okay. I'm going to open up file, new. I didn't load it. Okay. Where am I? I'll load this into the project. Okay, so it's there. Now what's interesting is I can click on this. We can edit type and change everything here. But the extrusion, the height isn't changing because it wasn't a variable, right? I just made it that height in there. I didn't make it a parameter. Right. So different ways of making it a parameter. We do that. Well, we can go back in. What are the ways we could do it? I could touch the object I made, and I could make a parameter here and say height. Right, would be one way. But we might want to have some fancy controls with this, or let's look at when you're making a generic model. Let's look at the front, and then all of a sudden we've got reference layer. Here. Do RE, draw another line here, and now I'm going to dimension this. I'm going to make this overall. Okay. Now this is interesting, is that we're going to want a crazy column cap to this. Like this is going to be the plane where the structure is. This column doesn't go up to the plane. It's held back from them, right? How much is it held back? Held back. Let's say a foot, just to make it easy. So watch, so I'm actually dimensioning this from up here. So I grab this, and I'm going to say 1 foot. Notice I did not dimension from here down. I didn't lock, so watch. So if I was to do the dimension from here to here, those are competing and locking against each other. So I can actually say, hey, look, no matter what, I always want this to be locked at a foot. Now I can come in and change my height to 22 feet. And that goes out, but hey, the column didn't move. Well, it doesn't matter. That's just, hey, that and lock.
So instead of, there was telling the object to change, or just telling the object to lock to a layer that's being determined by something. This can be, there's a lot of complexity you can build into stuff by understanding one dimension and how everything else wants to respond to that dimension.
This is all including capacity.
Right. Because when later when I'm building, I'm gonna make the surface for the structure. And I have a base, but the column's not gonna be that full height. And so I don't want to go in and tell it to be shorter every time. I want it to be a certain offset, right? Now I'm setting that. I was showing that you can lock it. We might also make that a variable and we could change it where we want. And that could be smart because let's say we want this column. Well, yeah, it's sort of, if you wanted a different connection, I'm pretty sure that connection is going to be the same every time. So I'm going to do.
If you want.
So if because the connection between the column and the structure is going to be the same connection every time, I would then want it to be fixed. If I wanted, because the column height will still change based on where the overall height, right? I can make short ones and tall ones, but it's still the connection that's the same. So this would be one we could file, save as family. Again, I go into mine. And I have generic model, generic. And let's call it a Mies column.
So when you said that if you know that you need to put some 3 different weights with that 1 foot space for connection, would it be easier to make it not fixed or just to duplicate this column?
So if I load this into the project now. Boom, boom, boom. I'm gonna delete this first one even though it should be updated. Okay, so if we go into families, generic model. We should have Mies Museum. I'm going to double click on this, duplicate all. Right to, okay, let's actually. Okay, I should be naming it column and all that. Let's say, so you can have them all in somewhere and I can just grab these ones. Again, I can just grab this one and say, hey, I want you to be short. Now it's still gauged, the height was gauged by the other thing.
You only lock that.
The overall height was the parameter. I'm always locking that it's always a foot underneath that overall height, right? And there are times where that, because I might always want that certain connection to be there. Now we're going to build a connection. But so just different ways we could have it be to where it's an instance and always changing. So let's say that would be a challenge for anybody who wants to do something tough really quick. Let me stop share real quick. If you want to do something really tough, we could make a generic model column. Actually, I would probably just make it a 2-point adaptive. We could make a 2-point adaptive column, and then it would constantly be changing. We can make a topography, a crazy topographic surface, do nodes, make the same topographic surface at the top that's flat. Let's say Mies's roof. We could locate, snap the column, snap the column, snap the column, snap the column. That makes sense. And the column would change its height based on the topography, but we could still have the 1 foot offset. So there's always the perfect, right? So that would be making the whole thing a variable, or in like the difference between an instance one versus a family type. Me telling it to be different heights versus it responding in the moment. That's where the 2-point adaptive, the generic model adaptive is helpful if you want everyone to be different, right? Because you're just making it respond. But most of the time, 90% of the time, you probably have a couple types. Okay. It is the, and this is where, yeah. So, how we do the column cap. All right, so that'll be a generic model also. There's file.
So we're looking in plan. Yeah, okay, and so this is pretty much what I went through and did the first time. Let me actually, that'll be good. For those that I screwed up and didn't hit record, what we're gonna do is make the column pin connection. I'm gonna do it. It's not gonna be exactly what NIST is. I'm just gonna make a version of it. We can start there. So in the end, I want a plate. Plate below, 2 plates. I want kind of like a mount, like a thing with a pin connection in it. Like 2 of them this way and 1 of them coming down. Okay, so in elevation, say one big one going down like this with a hole through it, and then a plate down here like that. Okay, with a pin that goes through it. So that's the goal of what I'm making. I was cutting through this thing, what it would look like, right? And we're just gonna make this a thing that I just set in there. It's kind of like it. He's got kind of a nub that's incorporated, but let's just do this. I think this is a little more useful. Okay, so drawing that out in plan, this is what I did first with the other one, right? I have my reference line. I want line for its size. I want thickness of the center and the offset for the other 2. So there's, reference line. And then I'll want thickness for the diameter of the element, and an elevation will want height, thickness for those. And we'll want the pin location to be directly in the middle. So I'm going to try to make sure that pin location is directly in the middle. Okay?
Can you tell me the grid?
No, it's great.
When you draw the grid, I know you said that experience is fine. Would you suggest, is it more so like looking at elevation? Is that what you're going to be drawing? So if I know what this, what I'm trying to draw, what's happening, I'll be mad at grid based off of that.
Right. So understanding where you want it, this is depending on the object, you'll start to see where I try to control everything you can in one location, if you can, and then only try to control something in one other one. Like the more times you try and control it from different sides, the more you might accidentally have 2 things fighting each other. That makes sense. Because if you set up 2 parameters that fight, then it's like it can't do it. Right. Okay. So this is what I did the other time. The quick is just say RE, draw a line, draw it straight. Doesn't matter where it is, but keep it straight. And then I did a quick. Oh. But usually always do the equal first. I don't know. Sometimes it gets not itself. Equal. Oh, that's right. Okay, so this is what I did before is then I grab one of these and I say, hey, I make a parameter. This is going to be width, overall width. Plate width. How about that? Plate. Okay, and I can just grab this one. Plate width. Okay. You get out of the way. All right. Doesn't really matter. It's just nice for message. Now, what do we want here? The idea of that, and one more, and one more. So there's the 2 from one side, 1 from the other. And then we have, they're all going to begin. Actually, that might be enough. Actually, okay, no, that's be interesting. So let's control this. I want this. I want these all to be, ooh, I've never done this before. Let's see if this works. 1, 2, 3, off, equal. Okay, now I'm gonna see if this goes, if I can make this work. 1, 2, 3, 4. Did it? Didn't let me do that as equal. All right, so they're gonna be individual, and we're just gonna tell each one of them be the same. So those are equal. And we're gonna say this is it's the let's call it anchor width. Okay. And let's just set that to like 3 inches right now. Width. Just big old hefty plate of steel. Now I'm gonna make both of these. Grab both of them, hey. Them both to be 3 inches. Okay. Change this a little bit small. All right. So I'm just kind of controlling all this stuff, which is interesting. We're going to make create extrusion. And a lot of times I build like this. I purposely didn't do any of that. AA. And we could lock it if we want to be really safe. But if you think about it, like almost everything that and I'm just gonna leave that extrusion there. Let's leave it as it is. DD, let's see this object. Okay, I'm gonna go into front. Okay, see how like we can see the lines this way because that's the way the reference lines are looking. I'm gonna look from the other direction. Because those are going to be able to control when I move stuff. I want to be able to draw the other way. So you go back to the front. And it's watch what happens. Like it makes sense because I'm going to lock to those that way. So I want to draw the profile this way. Just you gotta set a bonus. So I'm going to draw a reference line here. And I'm actually going to draw a reference line here. I'm going to draw a reference line here. Another one in the middle. Now this makes sense. Again, I'm going to do the same thing before where I'm going to have an overall. Okay. Now I want to control these things based on it. I'm going to do this to here. I'm going to do this to here. Now, what are these going to be? The same. And they're going to be plate. I could have things that are locking against each other, right? So this is why I try not to have them in too many directions, right? So that's the way. This is my second one, right? So now I'm going to, and because I have the planes drawn the other way, I can lock to them, but they're already done, right? And they're drawn in plan because they're 3-dimensional planes. So now those are the same. And now this is interesting. I want this thing to be a center line. Equal. So now no matter what, that line's going to be in the center of that. Okay. What do we want? We want a pin here. So I'm going to say create extrusion pin. And just by me locking it here and going out, I could say, let's say that's going to be 8-inch. That is a hefty pin. I'm just going to hit OK. Now we could control that. I could go in here. I could double click it, click on that. I could make this a parameter, make it real and say new pin radius. Now that's the pin radius. That is an object. If I go DD, there's this pin floating there. I can go, hey, pin radius 2 inches. Okay, changing the size, right? Now what's interesting is I can go back to plan and I can say, I want that pin to be AA from here to here. Okay, so that's how we're going to use these. Is we've got them locked here. I'm going to make objects, but then I'm going to lock their planes there. So now we want to make something kind of based on this that goes around it. And this is what's interesting is because we have that size. I normally wouldn't change, like the pin wouldn't normally be there. I was just showing that you can change stuff. I probably would, this would all be set stuff, frankly, but for me, anyways. Let's make this Arctic extrusion, right? So, I do need, widths for this, which I can do in plan. So, this is the structure. I'm gonna go, where does this, what is the size of this arc, the anchors that come up and what's the word? The arches that go up and hold the pin equal. Ooh. So this is where I'm gonna make sure that this, we want to be really thin. Yeah, I don't want to be really thin. So this is interesting. We could change the width of this. We could make it so small that it wouldn't fit, right? So sometimes you want some smart features, but those features might lock on each other. So I might say, hey, if I always want a certain amount of metal going around the pin, I could say, hey, I want this dimension to always be the radius plus 4 inches. So no matter what the radius of the pin is, it's adding 4 inches of meat on the outside of it. So this is where I can say, hey, I want this dimension to be controlled and it would change, right? That could be pretty smart, but it could also get, man, we got 45 minutes. Let's try it. Okay, so this is, we're going to say, this is, we have anchor width. Not here, response. Okay. Now I'm going to go in here and say we have that radius, pin radius, copy, Control V plus 4 inches. Let's see if it works. Okay, so notice I cleared them all out because I'm just going to go back over here and say, okay, I have the left. We're seeing the pin floating there. I want to see the front. But now we can see where those lines are. So now I can grab stuff, right? This is great. So I'm going to say, I want to create an extrusion, create extrusion, and I can actually grab lines and say, hey, I want to grab that line. I want to grab that line, and I want to grab this line because it's going to be coming from there. And I want to grab offsets. Oh, let's just, you would want to offset it. You would offset it. Oh, let's just start. Let's see what happens. 4 inches. So I'll check. Whoop, start 4 inches. Okay, that was that. But maybe we want this to respond the same way that other dimension did. So I make the dimension real, I click on it, and I say, you are actually also that anchor response. Oh, I hit yes. It made an object DD. We see the object in there, but that's not what I wanted. It's just some big dumb object. So I go back to reference line. I say that big dumb object is going to be the middle one. AA, boom, boom, lock, boom, boom, lock. Okay. There's the pin. There's there. Go back to the front. I want AA, that to be locked to that, lock. I can actually grab this. You know what we're going to do? I'm going to do it super safe. I'm going to lock it. It says, oh, I thought you locked it over there. Yeah, I know I did. No, you know, we'll do that. It's locked to that. I'm going to go back to the floor plan because we want another plate above, right? So I'm just going to grab this and hide it. I'm going to say create another extrusion. Box really quickly. So what you got to think of is there DD, we see it there. I'm going to go back to the elevation and I'm going to grab this one. This is the new one. I can pull it up, and just set it there and lock it. I was hitting AA before. I can actually just pull it up and lock it. Okay, so we got our two plates. Locking to the thing. We got this always in the middle. So my overall would go down. Let's say two. Let's do two overall. 2 feet. That's good. Let's do 2.6. Oh yeah, we had 1 foot. Oh, so this whole thing. So we got to go back and correct that column. I think this is looking right. Should be right. Yeah. Oh, you know what it is these plates are way too thick. Plate thickness is 6 inches. No, let's do that. Like that's got to be like. That's why these proportions. That's better. Okay. Yeah. Okay. So we're just changing that around, but now we need 2 of these the other way, right?
So the thing is like copying and pasting when you're dealing with things that have parameters, breaks everything. As soon as you copy and paste it, the next thing has nothing to do with any of those parameters. So you don't want to do that. It's one thing about copying and pasting like a column around, right? Or copy and paste an object around. But when this is a smart thing. As soon as you copy, if I took this and said, just dragged a copy of it, that thing has no longer any intelligence with this. Right? It's like parameters no longer have anything to do with it. So that's not a good way to build it. So what we want to do is actually rebuild that other one. So we go to the side. Let's just do the same thing again. So we get one the other way. We're going to do say create extrusion. Same way, I'm just going to grab lines. I want to grab this line, grab this line, grab this line. And then we're going to do another one with an offset. And I'm just going to start with low edges just to get it there. That's fine. Boom, boom, boom. Supposed to there. And now I'm going to grab this one and again set this parameter to be that same one we already set before, which is that. And I say, oh, what's interesting is let's make. We can make, if you make a profile, it makes a solid object, right? But if you add another profile in there, it makes a negative already. So it just knows that that's positive and negative, right? So again, this is a big object here. We can go in plan, say I need this object A. No, I'm just going to put this flip there, block, flip. You know what? We're going to do it to here and lock. It's the whole way. And then what happens is, so we're seeing that pin, we're seeing this, but it's not real because it's an solid object the whole way, actually. So that's not real, right? So we actually want this part to go away in this section, right? But so I'm going to make an object cut away. Let's look at this side and say, I'm going to make another. Now this is weird because it gives you the void option. Sometimes have problems when I actually make it a void versus just making another solid object. Look at this, I'm just going to grab this and we'll go from here, go to here, say, okay. Here's this object I just made. Pull it through. Actually, I might lock it the sides that way. When it changes sides, no matter what the block, the negative will always. See, it was locking to this place by doing that. And now I'm going to say, I want to cut you with no. This really thing. What? Oh no, now I made it. So when I make it when I make the void, it cuts everything there. Now it's asking, what do you want me to cut? I want to cut you with that. But oh, you could tell it to be a solid or void. But when you make a void, it seems to cut through. Like you can't then tell it to not cut through something. Like it cuts through, like the pin would be cut, the lower would be cut. The idea is I want the void to cut this and not that. Much easier. See what I mean? Like watch. I'll do the same thing again. If I'll just Control Z, Control Z, Control Z, Control Z, Control Z, Control Z. Okay. Let's go back here.
that, and then, so now let's go back into the left side, that's where I drew it from. And said, if I was, oh, wait. Yeah, okay. So if I would have done it with a void extrusion, create void extrusion, same way. Yeah. It instantly cut through, but it cut through everything, right? It's cutting through that one and the other one. Yeah, I just can't seem to get the, you can tell it, because I can't, it's so weird, because it's like, there should be a way that I could grab this and say, like, uncut. Ah, never mind. Well, it says you do it. Yeah, never mind, you can uncut. So I've never actually seen that. So now the pin and that, so yeah, you notice even now the void is only going. Yeah, exactly. So either way, like make it a solid, make it a void till it's cut or. Okay, so now we got this, let's say file. Generic model, niece pin. So, different ways to think about this. Let's just load it. Let's load it into the project. Because there would be lots of times where you might have this at different locations. We could also say, and you could rotate it, spacebar, rotate, say rotating. Generic models do that where you just, this is where you can rotate them after the fact. But I want to, let's say SW, big, okay. So this would be one where I could be just picking the plane, or I might have a layer on there. So I just made that the work plane. Oh, you know what I would have done? Let's be, oh, one flip the whole thing upside down. Like logically, if I was really working on this project, I would have just realized that the work plane is above. It's dropping down, right? So with this logic, this is a little tougher logic to just like reinvent upside down. Because it's all reverse. So you can't just grab it. So I could do the dimension, the plan dimensions are all the same. I would probably rebuild it negative because I can't. Maybe if I go not always vertical, work plan based. Work plan based means you can set it on a surface or a wall at a weird angle, but you might be able to toggle it upside down. Let's see. That makes sense. Like no, no, I don't care about saving project. I never care about. See, this is where I can put it on the face. I can put it, it's like just reading whatever thing I want. We can we could take a center line of something, a line, center line. Well, normally I would have a grid line, grid for the project, columns on that grid. These things would be locked into that grid. That rotates. Can you flip upside down? I could probably grab the underside of the thing, and so that way it would go the underside of the surface of the roof. We could also put this in the column thing. So I could say load this into niece column. Go away, go away. What happens when we just drop it in here? Okay. So now let's look at this again and go back into front and say our height for that was 2 feet. And so I actually want to go in here and say this. Yeah. No, probably And we should be able to go. See, I'm not seeing that. So we would need a ceiling plan. We should be able to lock center line, baby. It usually finds in components, it will find center line. We can still click on this, edit type, all of our stuff. And this is where we could, if we really got fancy, you can have these things driven by the other ones, but it starts to fold in. It's incestuous. Okay. Let's just leave it at that for now. Save. That 2 feet, so it's there. So that way, so what this is, this should move around with the height of the thing. So when if I load this in and say overwrite all existing ones, it should put a column at the top of each of these. Other one, that was the one that was there. So, blah, 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 blah. Okay. So all the stuff we're doing with generic model adaptive, and generic model and all these things. What can you tell? Have you watched any videos on YouTube besides mine? And what was your takeaway from the videos you watched? What are they modeling? What are they doing? Just like when you watch them, like when you look at the sea of stuff on YouTube that's doing adaptive components or any of these things. Any of those things, yeah. Right. What I was going to get. Right. This is just like every tutorial that I watch in this stuff. It's engineering and it's IT people in architectural offices. So everything we're doing about setting up these components and setting up these rules, this isn't the world that architects normally play in. It's what the engineer or your computer IT person sits and sets. With the idea of like locking it, it's like, yeah, the person goes, I'm locking it so all of you don't get up when you play with it somewhere. Right? It's the idea of like making sure it's always right. And so you got to understand, like, I'm taking time to show you how to manipulate this stuff because architects don't do it. And so they're stuck using generic stuff for that certain thing, right? Or waiting for somebody to do it. And the graduates that I know that have gotten to know how to do this, it's so when you can model the unique thing pretty quickly and have it change, you get to be the one designing the fun stuff in projects instead of just doing the generic stuff in projects. And that I've like had students come back, they were like, I mean, one was really honest, and the student was like, you know, I wasn't the top student, the good student, very good student, but not like design. And they were just like, I get to do all the fun stuff because I know how to do this. And so they draw it out, we draw it out together. We understand what's going to be, and then I can go model it. And so I get to do the cool stuff. And it's like, it's just so much fun because it's effective to use, especially if you can set it up to where there's variables so you can change it. Now you're saving the office so much money, so much time. They're getting what they want, right? And you're having fun and then probably making some decisions because not everything's ever always drawn, right? So now you got to figure out how to solve that. But it does mean we're working in an engineering world and thought process, which is why it's tedious and everything's a variable. And there's, you know, these weird lines, right? So I get it. So how would we it's made for people just sitting around and doing that. So let's how would I put this together? First floor, any project, we need to delete this stuff. RE, just like anything, I start with drawing my reference lines. What's the distance? Total. Yeah, let's just go into 6 just to be easy. Ooh, that's. It should be divided by, well, that's really funny. It's 196. Oh, because I keep saying inches. Like, what am I doing? Well, my normal parameters are set up for like little residential projects, so where the elevation tags are just. Oh man, I hate when. Oh, you are driving me nuts. Just go. Go away. All right. Oh, what is 60, 60? 60, 60? How do we want to have, let's have some fun with this. Let's say, let's make this whole building parametric. I'm gonna take let's make it center. Let's be really fancy. Because we got some time. I want to make this whole nice building parametric. So I'm going to take these two center ones, and I'm going to pin them. You'll see. Instead of locking it, I'm going to make it all proportional. So from here to here to here equal here. I want this to be proportional. Weird. Let's just keep this as a set. That's going to be the 60 feet. This will be the 60 feet. That's the 60 feet. That's the 60 feet, right? But I'm going to keep, we're going to have. And the overall is going to be the same. Okay. So we're going to have overall width here, new parameter. What I'm showing you is that this is all, I'm in a project file. I'm not in a, I'm making the project this. Ooh. So this one. Well, that was equal. That was equal. So made each one of them that distance. It's like, why did it jump? I thought that was, I didn't realize that was the equal. I need the overall. Okay. This is the overall. Okay. Boom, boom, boom. And then I want this to be. We want to really fancy. Okay, let's. Boom, boom. This dimension is going to report. So we're going to make it a parameter. Yeah, it's just weird because it's in a different world, so I'm not used to it. So this is half building. We could just use the building wall. I could make this. That's weird. I'm gonna make it a reporting. Okay, I want this to be, it's not a third, we'll say, what is it? Because it's like 60 from 194, what is that? What's the proportions? Third, it's like 30, it's not 30%. It's not because it would be, but it's not a quarter. This still can't be right. So I counted it. Wait, we were just looking at the, when you look at the reflected ceiling plan, it's easier to count each one of these. Come on. So each one of these is 12 feet, right? 1, 2, 3, 4, 5, 6, 7, 8, 8. That's 96. So 30.9. So I'll say it's just straight 30%. That'll be fine. Okay. So now we want this one, and I want to. What's interesting is I don't know how to get into the parameters in a project file. Like, how can I rewrite parameters view? But like, it's letting me code, but I want to tell it that this thing is going to be controlled by 1/3 of whatever this dimension is. But I can't get into, in architect, like normally in file, there is, manage project parameters. That's those ones. Did I make the one? It's not in there. Who was that? Yeah, but it's not, so see what I mean? There's properties, that's those and that, but it's not giving me the other one, like when you're in here. And I do something, there's this one, right? So what is this? This is family types. That's what I get into. So I gotta get into in this project, project file. Need to manage family types. It's gotta be family types. You insert them in here. It's funny, I haven't button. I was gonna set it the same way, but. All right, well, we could have made that 1/3 of this thing, and then they would go in if we change the width based on. There's just not, there's not the button there. This is,
Well, that's like word, you see them here.
oh, where,
Go up, next to the dimension. That's on bracket, go down to the.
oh, but that's the type of, it's not the properties. It's not it's the actual like dimension logic. It's not, it's interesting. Well, no, it's just like it seems like that should be something you can do in the world since you can set up the parameters, but it's how you get into. I'll have to look it up. I just hadn't done it in the thing. It seems like shared parameters, maybe it's shared parameters. This is stuff that's groups. No, that's because I made one in here already, right? Yes, overall width should show up in something. That's what I was getting at, like whatever. That? No, that's actual sheets, you know, like. All right, well, I was trying to screw off and do something fun. Anyways. We'll go in and like making stuff parametric in the building. So I just have okay, set. I would still come in and set these things the way I want. Right, we can set them all up to be the distances that we want. You know. And so now, really, this is what kills you is that I just had you go through modeling your own thing. And then we could go structure, beam system with, what's this? I'm gonna go. So we just spent all that time making our own beam, right? We could control and do anything, or I could go into insert, load from here. Structure. I took this day and it was the very last. Oh, that's why I went structure and I went steel. And then I went not steel columns. Structural, no, watch, I'll download this, put in structural framing, steel. Flange, load in. Oh, here's a 79-inch by that. There we go, 6'1". And now I say this beam system. I want to draw a square. Okay, boom, boom. all the beams perfectly done. What's interesting is that you can actually go in. Now, you can't mess with them as much. And it's really, although you can come in and I can now go in and say, hey, families, you go into structural framing. There's one I just downloaded, one size, that. I can click and I can click random places. I can also click 3D and snap it at weird angles. But getting it to repeat and go on a weird form and all those things are things you can't do with it. So it's smart. It's also not totally smart. I would, if I was doing a real project, I would probably just do the beam and I would do, I mean, the beam system because it's so easy to just come back in. And I would actually do another beam system again, and I would do the exact same thing again. And what am I going to do with this one? Yes. I'm going to say beam direction that way. Oh, I got to, what was that go? No. Oh, it's too tight. Oh, so just grab it and say, hey, I want that beam system actually to be 12 foot. What? It's 12 feet. And I go grab this other one. I'm going to say beam system what? 12 feet. Oh, good go. Oh, okay. But so it's flat and it's simple. And you just want to respond. Yes, all those things work well. But being able to manipulate it to do what you want is how you own Revit. So I can't grab the corner of this and lift it up and flex. We can make a rake edge and have it adjust a little bit, but it's much fussier. Okay. So I always like doing that because then it's like, so like we create a whole beam system and say we want you to be like right now it came in first we could so that's kind of it for today. Unless there's specific questions. Bringing it all in here, I could drop the columns in. Then of course take the section box. Okay, have the section box turned on with my shadows. Let me just turn it back to line only. The section box. Cut the corner. So as soon as you get, the only thing I really have in here are these things. So once you get these set up, the sun regard, and then I might have edited the number of, I might have edited this a little bit the way that I'd like to see it. Like, because they're in alphabetical order. So I have like 0, 1, 0, 2, 0, 3, because I want it to be in all of them. So that's probably the only thing I did is just change those things. And then with nothing in the world, say just file, save as project template, and then you can make sure it's, you got to do, I think sometimes you have to do a little bit of file management to make sure it's in the pool that they give you as a template. Like I think I had to figure out where that file was. So I'm going to say file, watch when I go file new project. It just comes up here and I go browse. I figured out where this file was and I dropped mine in there. Once. Templates, these templates.
Yeah, like regular templates.
Okay, you can, yeah, okay, yeah, we deleted all the templates out of there. Okay. You can actually just go through and download like the Imperial from Revit. You could reload in Revit and then just move that stuff over. I was just being a little happy.
So that's why I to the news.
I'm on 22, but
Like I can say, The guy who this one, he's like, all I know is off. The boss ain't like, we like.
Well, because it used to be that all the stuff was there. All right, so tomorrow we'll kind of put one of these together, play around with exporting and diagramming what we had drawn out. So try to get some of the stuff modeled. Again, I don't care if you just download, you used to downloading the real one, build it in the world. You could throw in a normal column. The columns were pretty easy to make. It's kind of what we did, but
Are you gonna talk this up a little bit tonight?
yeah.
We can follow.
Yeah, do it as tense as you want, like either, you know, model all of it and or use like, because what was the other thing we could do? Actually, let's look at this really quick to be funny. Let's load in another structure. Insert this steel results structure. I will let's break that so weird. Connections. Steel structural columns, steel. This one, load. 14, yeah, that's good. Let's use that one. Okay, now watch this. So we just brought in a structural steel column. Structural columns, HP pile bearing, blah, blah, blah. Oh no, I have slanted column. No, I want vertical column. So it just is outside of the view. I just turn off the damn structure. So what would happen if I had this one and then I had another one, but I hit spacebar and turned it? We're getting what I'm saying here. Where are you? There you are. We can make the column, if you got the right size steel beams, you could just make the column pretty, you just gotta get the right size to look right. So there's lots of ways to do it. It's just, I think of the, we were making a full profile you could change for every time. There are ways of doing exactly right. And that, I guess that's what we're doing simple things that can be done the other way, but it's all the basic principles that you can do to manipulate stuff.
You can that really much.
Right, so especially if you get to where, like we could have done a different profile at the base than at the top. And so this is where, in a lot of, so let's screw it. Generic model. We could say, this is just something random, sweep blend, okay? What you're doing at blend is you have a top and a bottom, okay? And so you can actually draw one thing down below. And then a different shape down below. And this is what's interesting, is they're even being drawn at the same place, okay? But we can modify it after and all that. We can load in different profiles. So you could actually have the CAD drawing of an I-beam and a CAD drawing of a different I-beam and load it and make a form between the two. It's just like, hey, we get it. We want, you know, this is the weird part. The fact that it's like, this is the weird one getting used to. It's because it's just saying you're telling it how far to extrude later. It's not actually part of the modeling process. So some of these, the sweep you can, so this is where sweep you can load a profile. So we could load in, we could just draw a line, sketch path. Let's just, we can actually select. Select that. Okay, we can select a line. And then we say like, I want to load in a profile, and we could load in profile that we drew and a different profile we drew. So if I wanted to make that column tapered, I might draw the profile parametric and save two versions of the profile and lock them in, and now I get. I just don't want to have to do that today because if it might take me 2 to 3 days. Well, it's also like, so what happens is I don't do this for like 6 months. And so then all of a sudden it's like, I'm standing into like the last week. I was like, okay, just run through stuff. I give myself the model. So it is one of those, as soon as you're deep into it, like when I think back of when I was modeling that project and like the Illustrator, like how Illustrator is second nature when I'm in it. All of a sudden it's like, well, I've been open Illustrator in a few months. And it's like, so just the damn commands and thinking through the layering, you know, it's like, it takes, as soon as you get your head, you're like, oh, this is how I manipulate stuff in Illustrator, right? Because when I think back to those presentations, those things, I was just sweeping, grabbing, changing language, sweep, color, fill, like they were fast. But I had been working, I was getting paid to work, so I was working. You know, like how much I was paying attention was different. So, you know, by the end of this, we'll be screaming fast, but I get that it's really not fast at the beginning, especially when you're first learning. It's not, I can tell I'm slow because I just hadn't been doing it because I was screwing around during fall a little, or during spring a little bit, but wasn't doing a lot of students, so. All right. I'll upload this as soon as it's available.